This is lecture 3 of the subject, integral calculus. And in this lecture, we are going to discuss the use substitution when we have inverse trigonometric functions as our integrands. So let us know the basic or the standard form, standard inverse trigonometric forms. We only have three. Integral of dx over square root of 1 minus x squared. The antiderivative is arc sine of x. And then dx over integral of dx over 1 plus x squared without the radical sign. Plus ya. Pag plus, arctan yung antiderivative. And the third one is integral of dx over, if we have x outside the radical sign, and then inside the radical sign or the radicand, the first term is x and the second term is a constant. Then the antiderivative is arc secant of x plus c. So to generalize, we have this one. Instead of 1, we will use another variable sa constant. And then instead na x, we'll replace it by u. So this is the general form. Integral of du over square root of a squared minus u squared. Instead of 1a, squared lang. And the antiderivative is arc sine of u over a. Same rather, eh? No? If we replace a by 1 and then replace u by x, dx, the result will be arc sine of x over 1 or simply arc sine of x. For tangent, we have 1 over a. 1 over a arc tan of u over a. Or you can derive this one if you want. And the third one is u. If you have this form, u outside the radical sign, then u squared minus a squared, that's 1 over a arc secant u over a. So uh, what you're going to remember is this. If the radicand starts with constant and then variable, that's arc sine. Minus arc sine. But if it will start with variable and then constant plus variable outside the radical sign, that's arc secant with 1 over a. And then if there is no radical sign and then plus and then arctan niya 1 over a sa nata 1 over a. Um, pero if the radicand, if the integrand does not fall aning three forms, you can use other substitution. You can use the basic substitution. Okay. Like uh, a squared minus u squared. Of course, the the antiderivative is not arctan because negative man. So maybe you can solve it by simple u substitution or square root of a squared plus u squared. Uh, So it's not arc sine. Okay, so uh, y- uh, this will be the result only if these are the forms. Okay. Yeah. Let's try to solve some problems. Okay. First one, evaluate integral of r dr over square root of 16 minus 9r squared. So, a 9r to the fourth. No? So, since the radicand starts with a constant and with a variable, then kung i-fit na to, nasa, dali, this is the form, constant and then variable. So, uh, and probably this will result in this in antiderivative. So first is we have to express each term's radicand into a perfect square. So 16, it's 4 squared, and 9 r to the fourth, it's 3r squared quantity squared. This one. So if we will fit this one sa standard form, this is our A, 4, and this is our U, 3r squared. So let U equal to 3r squared. Derivative of 3r squared is 6r dr. And so we can replace r dr by du over 6. And so this is the next step. R dr replaced by du over 6. And square root of 4 squared minus, this is u squared. And then 1 over 6, you place it before the integral, and we have this. And we'll fit this one's standard form. The antiderivative is arc sine of u over a. So the arc sine, the antiderivative is 1 over 6 arc sine of u over 4. And then finally, you replace u by its initial expression 3r squared. So the integral of this is equal to this one. U replaced by 3r squared. Okay. Next, since we don't have a radical sign, then this will fit the arctan form, no? Standard form. So express the denominator by perfect into perfect squares. So 9x squared is 3x squared, and 16 is 4 squared. So this is our A and U. So let U be equal to 3x, du equal to 3 dx. And then substitute dx is du over 3. We have this one. Du over 3, 3x replaced by u squared plus 4 squared. And you write 1/3 before the integral. You have this. And let's fit this one. This can be interchanged kay positive man. So the antiderivative is 1 over a arctan of u over a. So you have 1/3 plus times 1 over a, 1 over 4 arctan of u over 4. So the final answer is you multiply that 1 over 12 and you replace u by 3x. Okay. It's very simple. And for this one, integral of 2 dt over t minus 3 times square root of t squared minus 60 plus 5. So since we have this term outside the radical sign, it gives us an idea that this will fit the form of arcsecant. So our problem here is to make this one perfect squares, difference of two squares. So, okay. So this is what we are going to do. We will use completing the square. So from this one, t squared minus 60 plus 5. Okay. The process of completing the square is for these two terms, t squared minus 60, we are going to add a third term to make it a perfect square, like this one. Okay, let's group this t squared minus 60 and then 5. So to make this one a perfect square trinomial, we are going to add a third term. But at the same time, we will subtract the same term so that it has no effect sa original condition. Okay. So we'll add a third term and then subtract the same value so that in effect it's zero. So how to get this third term? So completing the square is you divide the coefficient of the first degree term 6 divided by 2. 6 divided by 2 is 3. The result is square mo. So 6 over 2, 3. 3 square is 9. And since nag-add ka og 9, you also subtract 9. So that in effect 0. So the result is this term, this trinomial, can be written into a perfect square trinomial. T minus 3. T minus 3 squared and plus 5 minus 9 is negative 4. So this is the result. T minus 3 squared minus 4. Because if you will expand this, the result is this. Okay, so from this one, we'll replace it by this one. T minus 3 squared minus 4. And so this will now fit the arcsecant form. This will be our u sa day. So let u t minus 3 du, it's just dt. So this is the result. 2 du over u times u squared minus 2 squared. So ang form niya is this. So the antiderivative is 1 over a arcsecant u over a. So put number 2 before the integral, and then the antiderivative is 1 over a, again, 1 over a arcsecant of u over a. So 1 over a arcsecant u over a 2. So cancelled. And finally, the integral of this is arcsecant, no coefficient, arcsecant, replace u by t minus 3. And so you have this. Okay. So once, if you encounter problems similar uh, that will fit the three forms, that will fit these forms, and these are the antiderivatives. But if the original integrand do not fit this one, then you can use other substitution. So that's it. Thank you for watching.